Hey, what's up, guys? It's Mr. Good. I just want to go over 7.1 and 7.2. I know some people have some questions. It looks a lot more confusing than it actually is, especially if you know how to use a calculator. So there's a video on my website, or my webpage rather, on parkcityprep.com or .org rather, that explains how to use it with a TI-30 X2X, which most of you have. But there's other ways to do it, depending on the calculator that you have. If you have a different type of calculator you can't figure out based on how I'm showing you on this calculator, then just email me and I'll try to look it up for you. You could also YouTube it, or Google it. Just type in, whatever type of calculator that you have, and then Google it that way with the cube root. All right. So for 7.1, it's pretty basic as far as the square roots are concerned. Okay. And I'm going over 7.1 and 7.2. So for the square roots, again, it's just a matter of looking at numbers like this. 8 times 8 equals 64. That means that 8 squared equals 64. This also means that the square root of 64 equals 8. Okay? So this is like a fact family. The same way we say, 2 times 3 equals 6. 6 divided by 3 equals 2. 6 divided by 2 equals 3. 3 times 2 equals 6. All right, so these are inverse operations. So you're going to see a lot of times when there's a variable involved, that's when you're going to use the inverse operation. Okay. For instance, if I say n squared equals 49, the opposite of squaring is a square root. Those would cancel out, just like when we multiply and divide, and they cancel out. And we do the same thing on both sides. So this would be n equals the square root of 49, which means that n equals 7. Okay? And you can plug it back in. You can say 7 squared equals 49. 7 times 7 equals 49, which is a true statement. So that's basically everything as far as the squares are concerned. I don't want to spend a whole bunch of time on it because I know I put up a couple pretty good videos and I touched on it last time as well. The vast majority of what I want to talk about today is 7.2 in the cubes, because it's something that you haven't really seen that much of. And like I said, it could look intimidating, but it's not really as difficult as it looks. So what I'm going to do is I'm going to go through a couple of the examples that you guys took notes on and make sense of them. And then I'll do some of the exercises that you guys did for classwork yesterday. All right, so the first thing I want to talk about was 7.2. All right. This is example number 1. This is from the textbook. It's on page 296. All right, so example number 1, they just want you to basically evaluate each expression. So the first one they show looks something like this. 2 times the cube root of 216, I'm sorry, negative 216, minus 3 equals 2 times negative 6 minus 3. All right. And they just want you to evaluate this expression. So basically what you have here is you have a cubed root on this side, and you're also going to have a cube root on the other side just to make sense of it. All right. And I'll break it down for you exactly what I mean. But the first thing that you're going to do is you're going to break down this side. 2 times negative 6 equals negative 12. Right? We know that these are going to cancel out. right? Because they're the same on both sides. So you're going to have 2 times the cube root of negative 216. All right. So now we're going to divide both sides by 2. We're going to have 3. I'm sorry, the cube root of negative 216 equals negative 6. All right. Now, to find this cube root is real easy. Just going to use your calculator here. All right. So we have this button right here above the arrow. So we're going to say 3 because that's the cube. All right. If it was the 4th root, we use 4. Square root, we use 2. All right. But second and this arrow, that will give you the cube root of whatever number you're looking for. In this case, we're looking for negative 216, which is negative 6. The way they broke it down in the book, I think there is an error because I see on the left-hand side is blank. But basically, the way this breaks down is both sides are equal. All right. So this side equals negative 6, and this side equals negative 6. Excuse me. You could have also just canceled these out, right? 2 and negative 3, 2 and negative 3. And you just seen that all of this, the cube root of negative 216 equals negative 6, like that. And we proved it here, we broke it down, but same thing. Let's see here. All right, so this is what I wanted to show you guys that's really important, because this is going to come up a lot and I don't want you to be confused. So we got the cube root of 125 cubed plus 21 equals 125 plus 21. All right. So just like when we say up here, when we had the square and the square root, those canceled out. These are going to cancel out as well. All right. Because you have a cube root and a cube. So those are going to cancel out, the cube root and the cube, and you're left with 125 plus 21. So you're left with 146 equals 146. So whenever you see this, just cancel it out. Whatever's inside the cube root, that's what's going to be your answer simplified, or that expression simplified. All right. I want to go over a couple of other examples. Like, for instance, when you have a fraction, it works the same way as a square root. All right. Except you're taking these individually. All right. So now you're going to take the cube root of 1 over the cube root of 64. Basically, what this is saying is what number times itself 3 times equals 1. What number times itself 3 times equals 64. And after you guys work with these numbers, you know, on a consistent basis, you're going to start to see numbers that pop up a lot. 64 is one of them. The cube root of 64 is 4 because 4 times 4 is 16 times 4 equals 64. So 4 cubed is 64. The cube root of 64 is 4. All right. It doesn't matter what root it is of 1. It could be the 100th root of 1. The answer is always going to be 1, because that's the only number you can multiply times itself to get 1. So that's always going to be 1. If this was square, it wouldn't matter. If it was 4th root, it wouldn't matter. And then we say, you know, cubed. I'm sorry, the third root, cubed root of 64 is going to be 4, like what we got down here. So this right here, I know it looks confusing, but it's really not as bad as it looks. It simplifies to 1/4. And it broke that down for you in the book. It does look a bit confusing. I hope I clarified a little bit with this example. All right, example number 2. Actually, we'll skip that for sake of time. We'll go down to, let's actually just go straight to the exercises. All right. So on page 298, the classwork from yesterday. All right, you guys had numbers 1 and 2. Some of you had odds, some of you had evens. I'm gonna go over both of some of those. Not all, obviously, for the sake of time. But I'll go through this for about 15 minutes. All right, so on page 298, the exercises. We have, is 25 a perfect cube? What this means is, can a number, a whole number, multiplied by itself 3 times equal 25? It says explain. So in this case, the answer is no. There's a couple ways you could answer this. You could say, there's no number that multiplied by itself 3 times that equals 25. Or more simply, you could say no, but it is a perfect square. You know it's a perfect square because 5 times 5 equals 25, but there's no number cubed that equals 25. All right, there is, but it's not a perfect cube. It's going to be a decimal of some sort. For number 2, can the cube of an integer be a negative number? So this is a good question. This is not like squares. Squares, there's no negative number you can multiply by itself to get a negative number, right? -2 times -2 is +4. -7 times -7 is +49, right? These are squares. This will be -2 squared. This will be -7 squared. But when you're talking about cubes, because you're multiplying that positive by another negative, right? So if I say -2 times -2 times -2, okay, this equals 4. That's positive. But now I'm multiplying it times another negative, right? So that's going to give me a -8. So the cube root of -8 would equal -2. The cube root of a +8 would be a +2. Same thing is true for if you multiply 49 times -7. All right. So to answer number 2, the answer is yes. Because the exponent, and we talked about this a little bit when we did exponent properties, is an odd number. And you could also say the root, if you're looking at it, based on the cube root, as opposed to, looking at it this way. But basically, when these numbers are odd, okay, you can have a negative product or negative answer. All right, so that's the gist of those two. Those are very important for the rest of the section. But let me go through some of these other questions. I'm gonna go through the odd problems. I know prep had odd yesterday and ACAP has odd today. So when we're talking about a cube, right? I'm just sketching this real quick. You know, all these sides are going to be the same because it's a perfect square on all the sides. So remember, the formula for volume of a cube is S cubed, or S times S times S. All right. In this case, they're telling you that the volume is 125,000 cubic inches. So what we're going to do is we're going to rewrite the formula and equal both of these to each other. So we're trying to figure out what number times itself 3 times is going to equal 125,000. All right, and the way we solve this, again, you do the opposite on both sides. So we're looking for the cube root. Those cancel. Cube root. All right, so to find the side, it's going to be the cubed root of 125,000. Nobody's expecting you guys to know what that is off the top of your head. All right, so what you're going to do is, again, you press 3 for the cube root. You got to make sure you hit that number first, right? Then you're going to hit second up arrow. It's right underneath the pi sign, okay? And then you're going to put the number inside the cube root. So it should look like that. So my answer is going to be 50. 50 inches. And I could check it. I could say 50 cubed, or 50 times 50 times 50. There's an easy way to do this. You just multiply these 3 numbers. 5 times 5 times 5 is 125. And I got my 3 zeros. 1, 2, 3. Like that. So that's the way you do this one and number 5. Number 5 is the same thing, even though it's a decimal, but you're going to work it the same exact way. All right, so I got my cube. Side, side, side. The volume is going to be S cubed. For this problem, it says 0.064 cubic meters. So we're going to equal these to each other. Doesn't matter which way you do it. You put this first or that first, doesn't matter. So again, the opposite of a cube is a cubic root. Those cancel. Doing the same thing on the other side. So again, let's say second, I'm sorry, let's say 3 second root, okay? And then we're going to plug in our decimal, 0.064. You're going to see it's 0.4. So we're going to say 0.4 meters. And again, you can check it, put in your calculator, multiply this times itself 3 times, and you'll get this. All right, that's basically the gist of everything that you're doing in this section. Same thing for like 7, 9. I'm going to do 11 just because it's a fraction, but it's done the same exact way. You just got to break it up. So when you have a cubic root, again, you got to do these individually. The numerator and denominator, we got to find the cubic root of those individually. So you're going to rewrite it like this. Okay. You're going to ask yourself what number, and some of you, you know, might be able to say in your head what number times itself 3 times equals 343. You're going to see 64 a lot, 8 a lot, 27 a lot. That's the cubes of 2, 3, and 4. So you might memorize these. After that, it gets a little bit more challenging to remember, but doable. So we're going to say, again, the cubic root of 343, right? 7. 7 times 7 is 49. 49 times 7 is 343. So that's going to be 7. Cubic root of 64, we already said before on the last page, that is 4. And right here, basically the same thing. And that's your final answer. You don't have to simplify this. Your final answer is 7/4. All right. Next, evaluating expressions. So for number 13, again, just like I told you before, don't be intimidated when you see like a cubed root with a cube. It's actually there to help you. It's not there to trick you. So what they want you to understand is that this cubic root, this and that cancel, all right, because they're opposites of each other. So what you're left with is -1/8 plus 3 3/4. All right, so you're just going to put that into your calculator. Put that into your calculator. -1 ABC8 plus 3 ABC3 ABC4. You get 3 5/8. That's it. So that's all you're really doing with those expressions. All right. I want to go over 15 because I want you to understand that you could have, you know, a number in front of a cube root. It's just like multiplying. All right. But you do have to use PEMDAS with this. For PEMDAS, the cube root acts like parentheses. It's like a grouping. So you got to take care of the cube root before you do anything else. So like for number 15, you got 1/4 minus 2 times the cube root of -1 over 216. All right. So I will rewrite this. I would say 1/4 minus 2 times the cube root of 1 over the cube root of 216. Again, whenever you're finding the root of a fraction, you got to do them individually. The cube root of 1 is 1. Cube root of 216 is 6. All right, so my next step, remember, you always got to use PEMDAS, is to multiply. So I have a -2 times a -1/6. So I'll just put that into my calculator. -2 times -1/6 is a positive 1/3. Now when you add these up, you're going to get 7/12. So that's your final answer. All right. I'm going to go over a couple more. Then we'll stop. I'm going to go over number 18. For those of you in AP that might have had questions on that from yesterday. So the key here is that n equals 500. You got to plug that in to the expression. So you got a cube root of n over 4 plus n over 10. Then you're just going to plug the number in. So cube root of 500 over 4 plus 500 over 10. Now, for these, when you can simplify what's on the inside, you should always do that before you find your cube root, because then you're going to have decimals. You don't want to have to work with decimals unless you absolutely have to. All right, on some of the other ones, like these fractions we did, sorry, like these fractions that we did on the last page. All right, you know, you cannot work with these fractions simplified because it's going to be a decimal. So that's why we had to take, you know, the cube root of 1, the cube root of 8, so forth and so on. All right. Cube root of 1, cube root of 216, rather. For this, these simplify because you could divide 500 by 4. All right. And 500 divided by 4 is 125. So we're going to say the cube root of 125 plus 500 divided by 10 is 50. The cube root of 125, plug that into your calculator, right? Again, 3 second root 125 equals, you can say it's 5. So 5 plus 50 equals 55. All right. And let's see, number 19, I believe Prep had this yesterday. So 3 times, I'm sorry, the cube root of 6w minus w. Very important that you understand that this minus w is not inside the cube root. And we're saying that w equals 288. So we're saying the cube root of 6 times 288 minus 288. So we say 6 times 288 is 1728. And we say the cube root 1728 I got a decimal here. Hold on. Just want to make sure I put that in correctly. Okay. Yeah. I think I put it in incorrectly. The cube root of 1728 is 12. Because 144 times 12 equals 1728. All right. Then I just pushed the wrong number. But we got 12 minus 288. So this will be negative 276. So that's the answer for number 19. All right. But that's pretty much everything for 7.2. If you guys have any more questions, please email me. The homework for tonight is, you know, online along with the classwork. Just go onto my webpage. You can see what the classwork and homework is. For the worksheets, you gotta go to the Chapter 7 resources file that I put on my webpage. But again, if you guys have any other questions, just email me, and I'll email you back or do another video. All right, take care.